I'm going to do an example using the parallel axis theorem. We have 2 point masses, each of mass m, which are each a distance L over 2 from the rotating axis, which passes through the center of mass. The point masses are connected by a bar of negligible mass. We can say that the inertia is equal to the sum of the inertias for each point mass, which is equal to mr squared. And so if we add up the mr squared for each point mass, we get rotational inertia is equal to m 1/2 L squared plus m 1/2 L squared. In turn, this is just equal to 1/2 ml squared. Now let's do an example where the rotational axis is not going through the center of mass, but is instead going through one of the point masses. In this case, it is going through the mass on the left. Of course, this means that the rotational inertia for the entire system has changed. We can find the new rotational inertia one of two ways. We'll start by summing up the rotational inertia of each point mass again. In this case, that means the inertia is going to be equal to m times 0 squared plus m times L squared, which of course is just equal to I equals ml squared. Now let's do the same thing using the parallel axis theorem. So to use the parallel axis theorem, we have to use the rotational inertia that we found when the axis was going through the center of mass, which we know is going to be equal to the original summing up of the mr squareds, where r refers to the distance between the center of mass and the point mass. And then we also need to add in the total mass times the distance between the old axis and the new axis squared. This should simplify into this equation. As you can see, the two parts highlighted in the red are equivalent because we found this in the first part of our example. You can also see that the second parts of the equations are equivalent as well due to simple algebra. Therefore, simplifying further, we get the same answer that we did when we simply added the rotational inertias of the point masses. Although this is a very simple example, and either method will do to find the new rotational inertia, the parallel axis theorem will help you immensely with more complicated problems, or more complicated objects with different inertias.